So section 3 is all about proofs. So really, in this section, there's nothing new. It's just putting it all together and being able to form that logical, justified argument, how you move from the given to the prove statement. So just remember, you must start with the given. What do you know? What does the given give me? And create a linked, chained, one step naturally leads to the next argument in order to prove something. So we have lots of tools so far for solving proofs. You may want to consider how to organize these on your cheat sheet, on a reference guide, so that they're easy to access and easy to reference. So just for a quick review, we have vertical angles. Remember, that's one of the things we can assume from a picture. If I have intersecting lines, I know my vertical angles are equal. I may also assume linear pairs from a picture. Beyond that, I really can't assume anything. I must either be given it, or the diagram markings itself must show it, or I must be able to conclude it from other information. Complementary and supplementary, if I'm told that in words, I can write an equation. If I have the right angle box, I can potentially write a parts to whole statement, adding those up to 90 with my linear pairs. I can write a supplementary statement adding them up to 180. Parts to whole allows me to write those equations. And remember, that's a key element of proofs. I want to move from words and the picture into equations, because once I'm in an equation, then all of my algebraic properties like addition, subtraction, division, substitution all apply. In Unit 2, we had all of our parallel lines and angle relationships. We learned if we were given parallel lines, we got certain angle relationships, like corresponding were equal, alternate interior were equal. If we knew those angle relationships, that same side interior were supplementary, we could conclude lines were parallel. We just recently had the Isosceles triangle theorem, which said if I know the sides, I get the angles, or conversely, if I know the angles are equal, I get the sides are equal. We just got done studying all of our triangle congruence theorems, and remember there are 5. These only are used as reasons when you write a congruency statement, triangle something to congruent to triangle something, by. The only thing that goes in that by line are one of these 5 reasons. CPCTC is only after triangle congruence. You must know corresponding parts of congruent triangles. You must know triangles are congruent before you can use that. Reflexive is when something is being used twice. It's doubling up between 2 triangles. And then our 2 key algebra properties of substitution and addition or subtraction. So those are kind of the biggies when it comes to proofs. So let's go ahead and look at some examples. Remember, geometry is a pattern, not a formula. And so you are going to start seeing some patterns emerge. Like if I have a series of equations, I'm probably going to do a substitution. So just start to look for some of those patterns. I also recommend right now that you grab some highlighters or colored pencils, because proofs always make more sense in color. So the first thing we're going to do is we're going to create our T-chart. And I've kind of created a little cheat sheet over here of my popular items. And I'm going to start with the given. And the very first thing we do is we write the given down. That NQ bisects angle MNP, and that angle NMQ is equal to angle NPQ. And that's the given. So I go over to my picture and I mark that NMQ, this angle, is equal to this angle. That's from my given. So then I say, well, what does the given give me? And this is a straight angle relationship, so I already marked that. But what about this, that NQ bisects MNP? So NQ bisects the big angle. Well, if I know that, then I know that this angle and this angle are equal. And so I can write angle MNQ is equal to angle PNQ. And that is true when I go from words to an equation. That is definition of bisector. So now I have my picture marked. Now, I'm trying to prove my triangle's congruent. I'm trying to prove these two triangles congruent to each other. So I'm looking at those options and saying, well, which one? So already, if we think about it kind of like a process of elimination, I know two angles. So this one's off the table. I don't have a right triangle, so that one's off, and that one's off. So I'm really looking at one of those two. Can I find the angle? I know two angles. Can I find the side between the angles, or do I know something about the side outside the angles? Truth is, in this scenario, there are two correct ways to do this proof. You could prove this side and this side, MN equals PN, are equal by Isosceles triangle theorem, and then I would have the triangles congruent by angle, side, angle. Some of you may see that NQ equals NQ by reflexive, and then my triangles are congruent by angle, angle, side. Both are true. So I'm going to go ahead and use the reflexive, because that is just something that I typically look for. But if you saw that isosceles triangle and that those sides would be equal, that is a completely legitimate proof. So I'm going to write that NQ equals NQ by reflexive. Now remember, the order matters. This is a fold in half, so N is going to match up with itself and Q with itself. And then my last step is that triangle MNQ is equal to triangle PNQ, and the reason is by angle, angle, side. If you mark your picture, determining which of these theorems you have will just be a matter of reading your picture. So tune into the next videos to see more of the proofs done.